He is blathering. On the blue side, I would like you to multiply longhand without a calculator. No calculator. Multiply longhand. I didn't get to him because I had to help a student through some stuff Friday afternoon. So, oh well, I'll get it next time. So, I would like you to do this one. And then
those students that are normally released on part-time do not have to come back after lunch if you so desire. Prom meetings today, 2:05 in the library, involved in the staff planning process.
No calculator.
Be a part of our community and enter your art in the art show sponsored by.
I would like you to multiply and divide longhand, like you're back in second, third grade.
Date is March 31. Track practice starts today, Monday at 3:30. For those athletes not in a winter sport, meet the auxiliary gym, dressed, ready to work out. If you have any questions, contact Coach Knight. Tennis team starts March 14th. So go over and get more information. Make sure if you're only to play involved in tennis, and be signing up in the activities office. Spartan Athletic Booster Club, 2 $1,500 scholarships to male athletes and senior female athletes. Make sure you sign up. Fill out the necessary form.
No calculator. No calculator. You do math for real. Now you know why I get brownie points.
I spent like 10 minutes staring at one of the
$5 for all of that. I'm enjoying the night hanging food beforehand. Partners of the week, McKenna artist Caleb Rannick. Both showed huge improvements in their retest last week and are in those parking spots for this week. Great job, both of you. All please stand.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Everyone else? Okay. What'd you do in PreCalc today? Long division.
Yep, I'm doing it. I thought it's done actually. You just don't believe it, kid.
Okay, now this shouldn't be an absolute rewind 8-9 years because You did long division of polynomials last semester or year in Algebra 2, which is what we're reviewing today. Today is all review stuff from Algebra 2. You did it all before. It's just got to shake some rust off. Okay. Longhand multiplication is an organized system of distribution. If you didn't know that, the way that we're doing this, effectively what you're saying is 30 plus 2 times 20,000 plus 3,000 plus 100 plus 20 plus 3. You're distributing into that. But instead of a whole bunch of arrows, they just found a way to condense it. Now, the way that I'm going to do it is probably the old school way of longhand multiplication. There are different ways because there's different ways to distribute. You all remember 2 times this, 2 times that, 2 times that, 2 times that, 2 times that, and then what? Okay. Why are we putting that 0? Like, this is important for today's stuff. Okay, I'm now taking 30 times this stuff. So to ensure that it's 30, not 3 times stuff, I need to bump over into the tens place when I start. That's why there's a 0 there. And then 3 times the stuff, 9, 6, 3, 9, 6. Okay. Get out of here, Frank. Okay. Now the reason I show you all that is because it's the same, and then you combine like terms, right? You combine like terms. Making sure that you carry over place value. What I need to show you about this, I think I've mentioned this before in class, this is just a method of distribution. It is no different. Isn't this the ones place, tens place, hundreds place, thousands, 10,000s? Each of those mimics a polynomial in how they're set up. This is 1 is x to the 0. 10 is 10 to the first, or x to the first. 100 is x squared, 10 squared. The thousands place value, that's 10 to the third, or x to the third. The 10,000s place value is x to the fourth. So when I take 2x to the fourth plus 3x to the third plus 1x squared plus 2x plus 3 times 3x plus 2, I do it the exact same way. Because the way that we learned how to distribute, the way that we learn longhand multiplication is the exact same way that we're going to multiply polynomials. It's just now it's going to be a x squared, x cubed, x to the fourth, x squared, x cubed, x to the fourth, x to the fifth, because 3x times 2x to the fourth is 6x to the fifth. And the reason that they have everything lined up by place value is it's also by like terms. So I get to multiply polynomials like that. That also means I get to divide them like that. Did we remember long division? Okay. You say, how many times does 32 go into 2? No. Into 23? No. 231? Okay. And just pick and choose, right? If I take it times 6, that's 180, 192, plus another 30. Hey, that works, 7. I take 7 times the stuff. 210 plus 14 is 224. I subtract it to find out if 7 times this is 224, how far away from it was I? I was 7 away from it. And then I drop the next place value, like it's a little hot, and say 72 instead. And I start the process over. 72 divided by 32. And I take 2 times the stuff. And I subtract that. And I get 6, 8, right? Right? Yeah. And unfortunately, it's 2 again. Whoop. I take 2 times the stuff. Get 64. Getting 19. Now, when we were back in elementary school, you would what? Okay, depending whether they wanted you to go into decimals or not. If I said as a decimal, I would put a point, 0, drop a 0, and I just keep going. Okay, every time I wasn't able to finish it off, I just keep putting zeros and keep going. And then they showed us remainder 19. But what am I dividing by? I'm taking this number divided by 32, and then I had 19 left over. I had 19 30-seconds left over. I wrote it as a fraction. So all of this from the ancient days, right, back when it was just move numbers around, we have to know both long and synthetic division. Every year when I get kids come up to PreCalc and we do a couple of these long division problems, they say, can we just do synthetic? Yeah. Do you know when? Okay. I can only do synthetic division if I'm using a linear factor. Because when it gets higher, when it's a quadratic factor, particularly irreducible quadratics, I can't do synthetic. Now, there is synthetic division for higher order polynomials. Years ago, I made a bastardized hybrid between synthetic and long division for my PreCalc. And it worked. And it was like 5 times faster. But it's not an official method. So I just stopped showing kids because you're never going to see it anywhere else. I just kind of came up with it. We need to know how to do this longhand for when it's not linear. Okay, so that is a divisor. It shall go outside. Whoop. 6x cubed minus 25x squared plus 18x plus 9. All right. So you're always looking at the leading term of your divisor. Y'all remember what this is called? Ooh, who had it? Dividend. Okay. Dividend is the thing you are dividing. Divisor is the thing you're dividing by. Okay. I'm going to take the first term of my divisor and just work my way along through these terms just like I would with regular long division. 6x cubed divided by x. 6x squared. Now, most of these problems, they're designed in such a way that it comes out nice. What if that was 6x cubed as a leading term, and then I had 5x minus 3? Well, 6x cubed divided by 5x, you would have to write 6/5 x squared up there. You would have to write the fraction and then work with the fraction. Most of these problems are designed with integer values, so you don't have to deal with that. Just be aware, fractions are fair game. So, and then we always took whatever this was in the, what's the answer part called? Quotient. Heard a couple of you say it. Okay, I'll take what's in the quotient part and I'll take it times this thing, this divisor. And I'll distribute it in, getting 6x cubed and a negative 18x squared. Now we always subtracted that, right? Whatever that was. So when I subtract it, I can either do this or just change the signs. I recommend changing the signs because how many of us are going to forget to add the 18x squared instead of subtract it? Okay, so that is my recommendation. We will change the signs. It's easier to do when I've got the different colors up here. You see what's going on. Cancels terms, negative 7x squared. Drop it, little warm, plus 18x. Do it again. Start over. Negative 7x squared divided by x. Negative 7x, right? If you have to write it off to the side, negative 7x squared over x, like that, just to double check it. Okay. Take that times your divisor, getting negative 7x squared and a positive 21x. It's a positive 21x. I know I should be writing plus 21x there, but experience has told me, what am I about to do, right? And if there's no sign there, I know it's positive. So now when I change my signs, when I subtract it, I've got a negative 3x, drop it, a little hot, plus 9. And I start again. We'll say negative 3x divided by x is a negative 3. Negative 3 times the stuff is a negative 3x and a positive 9. And I will change my signs. Okay, so it's the same longhand division you've been doing since, what, third grade is long division? Isn't it multiplication facts is second grade, division is third, fraction stuff is fourth? Huh. Well, I mean, I know they introduce it, but like hardcore operations with it, like negative 4 1/5 plus 2 1/8. It was? Cool.
In the Virginia school system, they just slap you with multiplication and division, the whole lot of it in third grade.
Okay, so they bumped the multiplication up. And granted, remember, born in 84 here, so things are different. And by different, I mean now they won't cut the top and bottom out of a refrigerator box and put it around your desk so you don't touch other kids. So, the 90s were something. What does it mean when I get a 0 at the end? Okay, perfect. Use math words. It's a factor. Okay? This times this makes that. It's a factor. Just like if I took, say I said 150 divided by 3. If I go longhand on this, 3 into 15 is 5. 5 times thing is 15. 0, drop, 0, 0, 0. Yay! That means 3 times 50 makes 150. But couldn't I still break up 50? I could still keep going, right? There are more factors that remain. So that's what this question is asking me. It says, factor this completely if that's a factor. Y'all, I just got a quadratic. Six x squared minus 7x minus 3. Y'all remember AC method? Take 6 times negative 3 is negative 18. What factors of negative 18 add up to my middle term, negative 7? So I split my middle term, 6x squared minus 9x plus 2x minus 3. Cut that in half, say these two got a 3x in common, leaving 2x minus 3. Those got nothing in common, but I'll put a 1 as a placeholder, 2x minus 3. I take a 2x minus 3 out, leaving a 3x plus 1. Or you could have gone straight to the binomials. 3 is a prime number. So it's just guess and check the signs and factors of 6 in your head, if you're good with that. Until my 5th year of teaching, I thought that's just how you were supposed to do it. Because I was never taught that. I didn't have a genuine Algebra 1 course. I was Podunk, Emerado, North Dakota, graduating 8th grade class of 12 kids. I didn't even see a quadratic until Algebra 2. I thought you were just supposed to go straight to the binomial and do it in your head. Why can't everyone else do it in their head? Turns out that there's a method. Okay. What's my answer?
X minus 3, the other factor.
Okay, with the x minus 3. I just factored the quadratic at the end. I have to make sure. It says factor it completely. X minus 3 was a known factor. I divided, I got the quadratic left over. Now I factored the quadratic left over. There's my answer. Okay, I've talked about this before when we were saying find the zeros of the thing. Said it depends whether it says factor completely instead of just factor. Well, now we got the word completely in there, so we have to write out the entire thing in linear factor form. So, can we long division? You first saw this actually in Algebra 1. It was the very, very, very first time that you saw it. We didn't do a lot with it. Algebra 2, you did a good amount with it, and then we showed you synthetic, and you probably forgot it all. Come on, you. Come on. Frank, get with the program here. I want you to do both because there's a difference in flavor with them. If you got to go above that in the notes, that blank space. Okay, we didn't need that extra problem with our polynomials. Sometimes when I make my notes, I forget that I can zoom in and have a big blank spot on the board, but you can't. Oops. Okay, step by step, line by line, follow the process. This divided by this, write it. Distribute. Change the signs. Combine like terms, drop it like it's hot. Start over. Okay, and we do have to know. We have to know how to do it longhand. Synthetic is great, but it only works for linear factors. What happens when I have an irreducible quadratic that came from imaginary roots? And they say, go find the other ones. Okay? We have to know how to do it both ways. Both of them should come out as factors. Zero remainder. Before someone tries to call brownie point, yes, I know I have not finished them. It's not just divide, it's completely factor.
Yeah, but it's subtracting by negative.
Okay, that's why we're practicing. The most common errors with this aren't even the math of it, the concepts of it. It's crap, I forgot a negative. I feel like I'm freshman again. Okay? You got to be slow and careful with how you write it out. Honestly, if I wasn't switching colors in between my steps, I would probably goof a negative somewhere in there too, because that just forces me to slow down.
So you still do.
You times whatever you get here, you times that by that,
Mhm.
and you get this.
Yes.
Okay. And then you just keep
And then change the signs, combine terms, go.
Thanks.
Yep. How'd the division part go? More of a, I looked back at it and, God, missed another negative. Seriously, 2 times 5 is not 7. Like arithmetic errors, procedural errors like that, little stuff that, it just happens. There's a lot of moving parts here. When you get to your quotient, please remember to finish it off. This is x plus 6, and then factor this quadratic, x minus 1, x plus 2. 2x minus 4, factor this. I'm betting most of us can go straight to the binomials here, because 3 and 2 are both prime. So mentally checking, the only way that I'm going to get 3x squared is 3x times x. The only way I'm going to get 2 is 1 times 2. It's just a matter of which goes where. Okay? So is it 2 and then 1, or 1 and then 2 to end up with a 5x in the middle? Okay? So, one of these is correct, the other is not. The instructions, again, factor completely. Okay, on the second problem, on part B, do you see where you can still factor something? This should actually be 2x minus 2, 3x plus 2, x plus 1. That's factoring completely. Now, the pink part of it, that is linear factors. If they ask for the linear factorization of a thing, that's correct. But they said to factor completely. Again, you get into the difference in the wording here. The reason I really want to bring that one up to you is because, did anyone notice I could have just done every single one of the terms was divisible by 2. Okay? Now, watch what happens though. Divide 3x squared, getting 3x cubed minus 6x squared. Come on, Frank, let's keep up. Change signs. Get 5x squared, drop it, little warm, minus 8x. Take green. 5x squared divided by x, 5x times the stuff, 5x squared minus 10x. Change signs, 2x, drop it, a little hot. Do it one more time, 2x divided by x, 2 times the stuff. But, do I get the same answer? Okay, so I want you to put a note next to this. Yes, you can divide all of the terms if they all share a common factor. But when it asks you to factor completely, whatever you just divided by, you have to just kind of throw it off to the side here, kind of push it off to the side in a holding pattern, and then bring it back at the end. Okay? There's a difference between I'm solving for zeros, in which case the amplitude of a function doesn't matter, versus I'm factoring and dividing where I want the entirety of the function to still be there. Okay, the difference between these two things is that without that 2, you have a 0 at 2, a 0 at -1, a 0 at -2/3, positive cubic once each. Okay. If I don't have the 2, that's what I see. But the actual function, if I were to graph it, looks like this. Twice as tall. You see what I mean by it's going to have the same zeros. You're going to have the same linear factors, but because you just divided by 2 and yeeted that thing out of there and just forgot about it, you're missing the amplitude of that function. If I'm only solving, it doesn't matter. But if I'm dividing and trying to create the function, if I'm trying to find the extra zeros, if I'm only finding zeros, it doesn't matter. But if I'm trying to find the function itself and its parts, this does matter. And we don't stress that as much as I would like in Algebra 2. So it's something we need to bring up. Okay? This is just how we do it. Well, we just did it. We're good with that. But can you take what we just did and translate this? Most kids just see a bunch of alphabet soup. Do you know what these mean? F of x over d of x. What might that D, Q, and R stand for? A function divided by the divisor function is the quotient function plus remainder over divisor functions. Well, if I'm going to have plus 19/32 when I divide longhand, that means I can also do it with polynomials. Who here's got a job? Okay. What's your, if you don't mind me asking, last paycheck?
I haven't worked in months, so.
Smart. Okay. Let's say normally my paycheck, what, every 2 weeks, right? My paycheck every 2 weeks was supposed to be, I don't work a lot of hours, maybe it was like $306. What happens when you get that paycheck and it says 36?
That sucks.
That sucks. Why? But it's the same numbers. 36, 306. I mean, 0 doesn't really matter, does it?
It matters.
It matters as soon as you're talking about my money, right? Place value matters. What do I need to remember to do here when I divide? Okay. That's 9x cubed plus 0x squared. I need a 0 as a placeholder. Most common error in any of these division problems, Algebra 2 or PreCalc, is basic arithmetic. Oops, I missed a negative. But the second most common is forgetting our placeholders. Okay, and then on down the rabbit hole you go. I take 9x cubed divided by 3x, getting 3x squared. 3x squared times the stuff is 9x cubed plus 6x squared. You see how if I were to distribute that normally, and I didn't have this place value here, that 6x squared would be hiding out under a negative x. And you'd be like, whoa, wait, whoa, what? But they're not like terms. How do I put those two together? Okay, that's why we use that as a placeholder, just like we use placeholders when we do longhand multiplication and division back in elementary school. Change of signs, I got negative 6x squared. Drop it, a little warm. And have negative 6x squared minus x. Do it again. Negative 6x squared divided by 3x is negative 2x. Negative 2x times the stuff is a negative 6x squared, negative 4x. I change my signs, getting 3x minus 3, and I was so close. 3x divided by 3x is 1. 1 times the stuff is 3x plus 2. But when I go to change my signs, I end up with a remainder. Now, this isn't like elementary school where I can say dot 0, 0, 0, 0. And I'm definitely not going to say r negative 5. Okay? I'm dividing by the thing. And I got this much left over. So that's my fraction, my portion left over. I can either say plus a negative 5 over 3x plus 2 plus a negative, or I can just subtract it. Okay? So, same story, a little bit different flavor in it. Watch out for placeholders. When you get to your remainder at the end, make sure you write it as a rational expression. Left, right. Okay. I'm slightly cross-eyed. Check my math on that one. Okay. The rest of the family was sick last weekend. I barely made it through conferences, and now it hit me like a ton of bricks. So I'm held up purely by pharmaceuticals right now. Well, at the end, you just bring this up, say minus 396 over x minus 5. Okay, that's it. Not too much tougher than saying remainder -1 or 396. Okay, just slow down, watch your watch the numbers. You know, because, right? Yeah, that one, I don't want to do that one again. We'll be good there. You know what? I do want to do 2a as well, because we're going to come back to it. There's a thing. We're going to come back to 2a after we talk about synthetic division, because it's kind of important. So I'd rather we just had the work for 2a in place so we can go back and talk. Okay, we are going to come back. I think we're good on the long division with these, but I wanted this specific problem on here because we're going to come back to it. It's got a thing. How do I reduce the remainder?
-1 over x minus 2/3.
Didn't expect anyone to say that. I thought I was going to catch someone doing it like a freshman, but not Jaden. Jaden's got this on lockdown. Okay, yes. If I took both numerator and denominator times 1/2, like anything times a half over a half is times 1. So I could have also written that as -1 over x minus 3/2. Okay. And that's important. Okay. That is going to come back to us when we come back to this problem. All right, but first we're going to talk about irreducible quadratics and synthetic. So we're coming back to 2a because it's going to be a good example of a thing we got to watch out for. All right, the reason we have to know how to do all that stuff is it's not always going to be a linear factor. If it's not a linear factor, then you can't do synthetic division. Well, you can, but not yet. First up, can I factor that quadratic? Are there factors of 7 that add up to -2? No. That's why I'm dividing by the entire quadratic, because the linear factors for this, -775 are x minus 1 plus or minus 5. The two linear factors. Okay? I'm betting you don't want to do division with one or x minus 1 minus I root of 6. Because then you have a bunch of compound numbers all over the place, and it's gross. You can do it, it's just disgusting. So instead, if I have the quadratic, well, why not just divide by the quadratic? It's the same process, you just got bigger stuff in there. Here we go. 2x to the fourth divided by x squared is 2x squared. Make sure that you keep it over the x squared term. Okay, you want things lined up by place value. You did when you were doing longhand multiplication, right? I'm taking this term divided by this term, leading term by leading term. Then I'll distribute 2x squared times all this stuff. 2x to the fourth minus 4x to the third plus 14x squared. Change the signs. Change the signs. I know that's a lot easier to see when I'm doing different colors like this on your paper. You ever kind of pause in the middle of it, maybe answer a question, and your friend next to you said something, then you go back and look at the problem, you're like, oh crap, did I change it or didn't I? Okay. Pros and cons. Cancels just a negative x squared plus 3x, and because I have 3 terms when I'm distributing, I will also drop this. Okay, I'm going to drop both. Do it again. Take a negative x squared divided by an x squared. So where does it go? Negative 1. Okay. Theoretically, I would have had a 0 here, or I would have had an x cubed term and an x squared term and only dropped 3x. Done another round of division before getting to the 11. In this case, because I had a double cancellation, effectively, I'm taking this step and I'm just not doing it. Okay? I just don't have to. Negative 1 times all that stuff is negative x squared, positive 2x, negative 7. Change my signs. Change the signs. Getting x minus 4. So my final answer, I don't need this, I don't need this, is going to have x minus 4 over that entire quadratic. Okay? Longhand division by something besides a linear factor. Okay, same process, just bigger, uglier. You? You. Mwahaha. That one. It's a difference if I'm saying divide it versus factor completely.
So what would you?
If I just say divide, yeah, you can divide everything by x right now. Yep.
Can you do that?
I would just have to remember that if I'm doing factor completely, it just means there's an x that came out.
Can you do it for both of those?
Well, you have to. Remember, it's your dividend divisor. They're the numerator and denominator of a fraction. So you have to take it out of all terms. Ooh, almost did it myself. Almost did it myself. Y'all catch the 0 as a placeholder? Your dividend has no x cubed term. Okay. I was halfway through writing out the problem before I caught it. Two x squared times the stuff. 6x to the fifth. Here. 6x to the fifth minus 4x to the fourth plus 2x to the third. 2x squared. Fourth. 2x. You see, it's the same steps, the same numbers. It's just the degree changed on them. Okay. Oh. Okay. Same process. Three x to the fourth minus 2x to the third plus x squared versus 3x to the third. There. 3x to the third minus 2x squared plus x. Change your signs. In both cases, I'm down to just 11x squared plus 15x. I'm down to 11x plus 15. You see how it doesn't matter if you took that x out or not. You're still getting the same quotient. See, one of them has x squared trying to divide by x cubed. Can't do it. The other has x divided by x squared. Can't do it. So they're going to be written as remainders, but look at what happens with the remainders themselves. 2x squared plus x plus 11x squared plus 15x all over 3x cubed minus 2x squared plus x. Look at the remainder. They all have an x in common. Meaning, if I were to divide without removing that x factor, I would now have to cancel, 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 cancel. All of that, instead, getting exactly what I'd have over here, 2x squared plus x plus 11x plus 15 over. Okay, so when I divide, again, it's a difference between am I trying to find zeros or am I trying to find quotients? If I want the quotient itself, I've got to keep everything in place. I divided everything by x. Do you remember what that means? If I have junk over junk, and I was able to cancel an x from top and bottom. Okay, x was taken out as a factor, it was canceled out, it was a factor that was removed from both numerator and denominator. Removable discontinuity, it creates a hole in the graph. So this is the graph I'll see. There's just going to be a hole back at x equals 0. Okay? So I'm guessing the longhand division, we can do it, we just don't like it. I don't like it. It's tedious. There's too many places to goof up. So I did a couple of these that were side by side, so we saw that the degree didn't even matter. The x's didn't even matter because as long as I kept everything lined up, as long as everything was in its correct space, the algorithm kind of took care of that for me. So that's where synthetic division comes along. Synthetic division says if it only matters what's a zero and what's a coefficient or constant, why bother putting all that alphabet soup up there anyway? Just work with the numbers. Okay? So they said, all of the x's are taking care of themselves, let's just get rid of the x's. And they turned it into synthetic division. The catch with synthetic division, remember every time we multiplied and then we subtracted. Multiplied and then subtracted. Because I kept doing that, think of opposite sign. It's opposite sign because I'm looking at the zero of that factor. So if I'm trying to divide by x minus 3, the zero of it is positive 3. I've seen this written two ways. Who saw it this way in Algebra 2? Versus just flipping the division sign upside down. Who saw it that way? Okay, it was like half of the class says nothing. Okay, right? It depends, right? Because different books and different teachers do it different ways. This is the way that this particular series of publishers does it. The books that I worked out of for 10 years did it this way. So that's just the way that I'm used to. Also, I'm lazy. I don't want to draw 3 lines. I just want to, done. Okay, it's your choice. I'm going to write it like this. You can write it like that if that's what you're comfortable with and what you're used to. But the process behind it is multiply and add and 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 multiply and add. Yes.
What's the line
Oh, because I'm taking a x to the third and dividing it by x to the first. What should my result be? If I take x to the third divided by x to the first, right? But I have 1, 2, 3 terms here. X squared, x constant. They put the line there to denote this is where my remainder will happen, because it's what's left over after I reduce it 1 degree. So I usually do my synthetic and then I put my line right there instead. But the idea is you take your very first term, drop it, little hot. Multiply, getting 18. Add them. Multiply, add them. Multiply, add them. Multiply and add, and multiply and add, and multiply and add. And you can go through synthetic division very fast. Okay. I take only the coefficients, making sure I leave a 0 as a placeholder. Only the coefficients, 0 as a placeholder. Most common error with synthetic division isn't even the arithmetic, it's that 0 as a placeholder. I will divide by the 0 of this, so I say x plus 2 equals 0, x equals negative 2. I drop my very first term so I can get the party started. That's a positive 2. And then, on down the train you go. Multiply them, negative 4. Add them, negative 4. Multiply them, positive 8. Add them, 3. Multiply them, negative 6. Add them, negative 1. Multiply them, positive 2. Add them, 0. And then I'll throw my little line in there denoting that's where my remainder is going to go. So if I took a degree 4 and divided it by a degree 1, that means this is now a x to the third minus 4x squared plus 3x minus 1. And 0 as a remainder, I don't have to write anything else. So much faster. Okay. I had a kid years ago end up in the quote book. He was running for student council or something, and after this he got mad and why haven't you shown me this, and I approve this message, and yeah. Like, this is just so much more efficient. But there is a catch.
Yeah, exactly.
Yeah, what was the story? Yeah, you didn't finish the story. What was the quote?
Oh, it was just, I approve this message. Or, no, he referred to himself in third person, too. Can't even remember what his last name was. Will something. Will something approves this message. And he would say it every time we ran into a problem that he could actually do. And that became a theme the whole semester. I'm going to say that's their fault because they interrupted me and ADHD go burr. And I already don't remember if that's true. Check the live. Yeah, okay. What's the 0 of this? 3 halves. Okay. Now don't think of it as 3 times 10 is 30, half of that is 15. Maybe half of 10 is 5 times 3. Or however you want to, whatever your brain does. Okay? Add them. Half of 2 is 1. 1 times 3 is 3. Add them. Half of 8 is 4. 4 times 2 is 12. I said 3 times 2. I said 4 times 2. It's 3 times 2. And is it 4? 4 times 3 is... No, I'm right.
I'm sorry.
That's how the list of shame started.
Get her on.
That's how the list of shame started. Is kids were intentionally messing me up so they could get brownie points. -2 and then... So, I took a cubic and I divided it by a linear. I'm now at x squared. X plus 8. What do I do with that remainder? Okay. So 10x squared plus 2x plus 8 minus 2 over 2x minus 3. That's wrong. Okay. I'd like you, right next to this, do it longhand. There's a method to the madness. Do it longhand right next to this. And see if you can figure out why. All right, fine then. We'll go back to that 2a. Okay? We'll go back to that 2a and then we'll come here and then we'll say what do we need to do. Okay? So I'm going to shove this guy. Is this going to hide down here in the corner? Okay, back to 2a. We already did this one longhand. You already have this answer, right? Do this one by synthetic. Do this by synthetic and compare it to your answer. First hour really likes math. Okay. I want you to compare the synthetic division answer to what you got by long division. Why is our synthetic division answer have the same remainder, but the coefficients on the quotient part are twice as big? Okay. It occurs back here. When I say 2x minus 3 equals 0, and then I divide, you have to remember that the thing I'm dividing by was 2x minus 3, not x minus 3 halves. Okay? So you divided by something that was half as big as the actual divisor. And it's an easy fix. Just reduce all of those down by whatever your denominator was. Okay? It's an easy fix. Your synthetic division was using a linear factor whose 0 0 might have been the same, but its size, its amplitude, was half as big. So I need to cut my answer in half as well. It won't change the remainder. So go all the way back to where we were. Okay, when we got this, all I need to do is, because my 0 was 3/2, I need to cut all of these coefficients down by half. Again, I don't mess with the remainder. The remainder takes care of itself because it's thing over thing. It'll reduce if it can. Okay? And this goes back to what Jaden said. Couldn't this also be 1 over x minus 3/2? Okay? But it wasn't. It was twice as large than that. It was scaled up. I have to take that into account with my answers. So please make a note about that, like big neon, oh crap, I need to pay attention to this. If I ever have the form ax plus b as a divisor, I have to divide coefficients and constant of my quotient by a. Okay? So like 4a, it's just x minus 3. The a in ax plus b is a 1. Dividing it by 1 won't do anything. I don't have to worry about it there. But on 4b, when I hit the end of the problem, I'm going to need to divide those terms by 3. Okay? And it's one of those things, honestly, I don't know that I've ever seen a book explicitly talk about that. They just expect that you can figure that out. So, A and B, watch out for when you need to reduce. Yes. Mm.
If you simplify the remainder, can you combine it with your answers? If it's like, for this one, if it's 9 over 1 that turned into a 9, do I add that to like the 2?
No, because it's over the denominator.
Oh, over the whole thing.
Yeah. Oh, you stay over there. Okay. 4, 3, negative 1, 8. Shoop, shoop. With 6, 11, negative 15, negative 12, 7. Shoop, shoop. With a negative 1/3. Okay. Multiply and add and multiply and add and multiply and add. Drop it. Multiply 12, add 15. Multiply 45, add 44. Multiply 120, 132, add 140. I took a cubic and divided it by a linear. I'm now at quadratic town, which means that 140 at the end is part of my remainder. 4x squared plus 15x plus 44 plus 140 over x minus 3. Drop it, little hot. Negative a third of is negative 2, gets a 9. Negative 1/3 of is negative 3. Add them together, get a negative 18. Negative 1/3 and negative 18 is a positive 6. Add them together. Negative 1/3 of negative 6 is a positive 2. Put them together. Again, I took a quartic, dividing it by linear. My last term will be remainder. But when I write my answer, I got to divide all of these by 3 as well. That's 2x to the third plus 3x squared minus 6x minus 2 plus 9 over 3x plus 1. Okay? While the random bouncing ball is going, 2 weeks from today, Pi Day. We didn't get to do Pi Day last year. I have confirmed my wife is going to do it again this year. That was the only in 14 years that I have not done Pi Day. Pi Day involves a lot of food. Okay? If there's anyone who has food allergies or requesting a particular type of pie, our household actually enjoys baking. It's one of the few things that my boys will do with her and not freak out. Like they're not going to, Connor's not going to run the other room and just topple an entire chair full of stuff. Okay? They will sit at the counter and just nicely, they love it. Okay? So, if you have any requests, most years she sends me to school with anywhere between 12 and 25 pies. Enough so everyone has one. Okay? There are, for those who do not like pie, like maybe you're a texture eater, okay? There's Grandma's pumpkin pie recipe that she specifically made for the guy who can't handle gooey stuff. It all gets thrown in a blender, poured in, baked, comes out like a brownie almost, where you can just pick up like a piece and just eat it with your hand. It's great. Crustless. It is. It's amazing. Every year there's a couple of kids who ask for the recipe. There's the chocolate chip cookie one that's not even a pie. It's just a really big friggin' cookie. Okay? But it's round, so we call it a pie. Okay? So it's a thing that we've always done. Yay for you. You're in second semester. You get food. Please write up there if you have any allergies, though, because she does take that into account to make sure that everyone can participate and do it safely. So, synthetic division, we cool with it? Synthetic substitution. See, okay, when I do synthetic division, I get all the way to the end and I get a 0. What does that mean? No remainder, goes in perfectly divisible, which means it's a factor. Okay, if something is a factor, that means it's a 0. If it's a 0, it's an x-intercept. If it's an x-intercept, it's a solution. And we solve polynomials by setting them equal to 0. So, some dead dude figures out, wait a second, if I do synthetic division and I get a 0, that means it's equal to 0. What if it was equal to 9, like the last one? What if I had this and put in a negative 1/3? Start typing. Let the calculator do the heavy lifting for you. Plug negative 1/3 in. And at the end, we get 9. Well, that was the remainder when I did synthetic division. And some famous dead dude comes up with the idea, wait, does that just work? Well, yeah, because what I'm doing is evaluating for the 0. I should get a 0 at the end if it's a factor. So that works for all of my numbers if I want to evaluate. It's called synthetic substitution because I will use synthetic division with a value C to find f of C. So if I have polynomial, apparently the math teacher is taking tickets at the football game because they came up with polynomial to determine attendance. Number of tickets is given by this equation. X is the number of games played. Use the remainder theorem. Remainder theorem means use synthetic substitution to do the evaluation, to find the number of tickets sold during the 12th game. So what they're saying is, I can do this right? The 12th game, plug in 12. They're saying instead of that, what I could do is say 1, negative 12, 48, 74, and just do synthetic division with a 12. Multiply, add. Multiply, add. Multiply, 144, 400, 576. 750, 7551. And then your remainder is the same as if you had just plugged a 12 into the equation. That tells me 650 tickets were sold at the 12th game. Now, why they needed a polynomial and had to throw it with football tickets, I don't know. But it's the idea that I can just do synthetic division, which might be quicker than all of that typing, because this is mental math versus what if I told you to do that with another fraction? Okay. So if they say during the 13th game of the season, you do the exact same difference, but I'll get him out of there, and I'll put a 13 instead. Go. 31, 13, 51, 61, 61, 610, 610, 187, 90, 808. I got 892, but I also went a little cross-eyed.
I think we got 860.
Yep.
Okay, 867? All right. And then I lose it. Okay, and not enough to finish it off. It's close. I got to make sure that the homework matches. It probably doesn't, so just bear with it. When I send it out on Remind, it's live. Tomorrow we'll come in, finish this off, and go straight into 2-4. There it is. Anyone who did not finish or take their test? Spartan time today, it's going to be a hop in place, just like any other test. Just come in, throw your phone over on the counter, get yourself situated. Okay? There's, I'd say, probably a dozen or more kids who have to finish a problem or two. If we're going a half hour plus on our tests and still have 3 questions left, that's bothersome though. Need to finish that last one. I understand sometimes you get stuck.